Hey everyone, welcome back to 197 Concepts. In this video, we will be discussing what is an inverting amplifier and how to design it in a Proteus, and along with that, how you are going to design a printed circuit board for it. Okay, so the printed circuit board part is just an assumption, not an assumption. It is just an approximate model, and when you go for the real application, so I'm going to do here it virtually, and when you go for the hardware part, there will be some changes. Okay, so in this video we are just going to make some virtual designs of the inverting amplifier. Okay, so first of all, you must be familiar with inverting amplifier. So it's nothing but amplifier that just inverts the signal, that gives a output signal which is 180 degrees out of phase with the input signal. So that's the inverting amplifier, and I believe you are familiar with the circuit, but let's have a quick recall. Okay, so this is my op amp, and this is the output that I will be collecting. For this, we will be having two terminals, that is the negative and the positive terminal. So this is called as a non-inverting terminal, whereas this is called as the inverting terminal. Okay, and when you give the input to this part, when you give the input to this part, it is going to give you an output of 180-degree phase shift. Okay, so if this is the input, then the output that you will be getting will be this signal. And since we are giving it to the inverting input, the non-inverting input will be ground. Okay, so this is the basic idea. Yes, of course, we will be having input resistors, the feedback resistors, and all. This is a closed loop resistor. You cannot closed loop amplifier. You cannot keep it as an open circuit. You have to keep it a closed feedback loop in this for getting a better result. Okay, so the basic idea is this one. You are taking an op amp. The IC number for this op amp is 741. Okay, 741, which is nothing but the operational amplifier. So you're taking the operational amplifier, the IC number is 741, and for that you are giving the input to the inverting pin, which will create an output that is out of phase with the input uh, with an angle of 180 degrees. Okay, for this we will be using Proteus, and yes, for developing the printed circuit board, or at least the virtual design of the printed circuit board, we will be using Proteus. So let's get into the circuit designing. And for that, what I'm going to do is I'm going to create a folder. Like we say, inverting amplifier. That's it. Now I will be searching for Proteus. It's starting up. Let's go for the new project. Browse. Then on the desktop, I have this inverting amplifier circuit folder. Select this folder, and what I'm going to do is inverting amp. Right, that's it. So I'm not going to change the template design and all. I'm just going to click on next until I get this finish button, and simply I'm clicking on this finish button. Now I get the basic project setup. From here, what I'm going to do is I'm just going to start my designing, and I'm going to select the components. The very first component that we need is definitely the IC741. So this is the IC741. Okay. Just observe the PCB preview. I'm selecting the component which is having which is already having a footprint, so that it will be much easier for me to place the footprint in the PCB layout. Okay. So yeah, I'm selecting this one. Then I need a resistor for the input side and for the feedback resistors also. Okay, for the feedback part also. So I'm going to take one resistor, and anything else that I need. No, it's just the feedback resistor and the input resistor to control the input voltage. That's it. Those are the things. Just a minute, let me confirm it. Yes, we just need two resistors, that's it. And now we are going to design it. So the very first thing, yeah, I have selected the resistor. So let's place the resistors itself, one here and one somewhere here. We will correct it after placing the op amp. So I'm selecting the operational amplifier, and what I'm going to do is I'm just clicking it and placing it here. Okay. Now this for the we have to give the connection to the inverting pin. So the R1 should be connected to the terminal 2 of the op amp. So in order to know what these pins are, you have to know the pin diagram. So let me try to discuss the pin diagram with you. So this is the pin diagram of the 741 IC, and if you can observe here, let me change the color first. And I will go with this. And if you observe here, we are already having a diagram. This is the diagram, okay? So this diagram is similar to the circuit that we have in the Proteus. So it is similar to this dimensions and all the shape and all. Okay. So what you have to observe here is the 741. This IC 741 is having a total of 8 pins. The IC is having a total of 8 pins. But what we are going to use is we are going to use this inverting input, pin number 2, pin number 3, pin number 4, pin number not 5, which is a positive power supply, pin number 7, and pin number 6. Okay, so this is offset null. It is used to correct the errors that comes because of offset. Okay, so and this is the NC, no connection pin. So if you can see here, this pin number 8 is nowhere connected to the IC741 or the op amp. So this is just a blank pin. You can say that. And the V plus, this is a positive voltage, positive voltage, and the V minus, which is the pin number 4, it's the, of course, the negative voltage. You might ask me what is the purpose of these voltages. The op amp is commonly used as a comparator. Okay, it is used as a comparator, and it is able to create a positive voltage output, positive voltage output, and along with that it is able to create a negative voltage output. So from the pin number 6, it is able to give you a positive voltage graph and a negative voltage graph. Now the limits of these graphs, the positive voltage and the negative voltage limits, is defined by this voltages. Okay, so that's why most commonly this says plus 15 volts and minus 15 volts. Okay, commonly this is the voltage that is used. Based on our requirement, we will shift for 12 volts also, plus 12 volts and minus 12 volts. Okay, so all these pins are nothing but, see, you are familiar with non-inverting input, and you are familiar with non-inverting input also. So non-inverting input will give you an output that is similar to the input, whereas inverting one will give the input that is similar to will give an output that is similar to the input, but with a phase shift of 180 degrees. Okay, and output pin, you are familiar with this. Then let's go to the circuit, and this is the one. Since I'm not using pin number 3, that is the non-inverting pin, what I'm going to do is I'm just simply selecting the ground, and I'm going to ground this pin. That's it. I'm just grounding this pin. Now I need a feedback. Okay. I just deleted that. I need a feedback so that I can take a part of the output and give it to the input. So I'm placing this here and I'm giving an output. Sorry, feedback. Yeah. Now we need to give the plus VCC and minus VCC, that is the plus 15 volts minus 15 volts along with the input signal. And yeah, we need a point to collect the output. So instead of collecting the output, what I'm going to do is I'm trying to see that in an oscilloscope the with the channel A. Okay, and in order to check the input, what I'm going to do is I'm going to use the channel B and connect it with the resistor. Okay, for giving the inputs, that is the DC voltages, the trigger voltages, or what we say, not the trigger voltages, the plus VCC and minus VCC to the op amp and the input signal. What I'm going to do is I'm just going to in the uh, generator mode and I'm using this sine signal. Okay, so yeah, I'm placing it there and connecting it to this one. And yeah, I need a DC part. So first of all, let's connect this. This will be connected to pin number 4 and this will be connected to the pin number 7. In order to verify which pin is what, so pin number 6 is the output and pin number 7 is the positive voltage. So pin number 7, this should be a DC with a voltage of plus 15. Okay, and this should be a DC signal with a voltage of minus 15. Okay, so that's the complete setup. Now yeah, we need to keep the values for this. We need to give the values for this also. So amplitude, I'm going to take it 10, whereas the frequency I'm going to select it 100 hertz. Okay, now I'm going to run this simulation. If you observe here, uh, this won't get enlarged. So I don't need channel C, I don't need this one, what we say, channel D. I just need both the channels. So observe here the A input. So the A channel gives you the output, whereas the B channel gives you the input. So for that purpose, I'm just going to reverse this. Okay, where is this one? This goes up, and let me try to increase this. Yeah, that's the thing. And when you go for the 2 also, it's the same input. So yeah, I am not able to move this. Only the channel 1 or channel A, channel B to move it along the x-axis. It's not possible. So if you observe here, I'm going to overlap these two signals. If you observe here, so this is a bottom point. This is a reference point. You can take it. Okay. So if you observe here, the amplitude of both the signals from the x-axis, from the reference line is same. Okay. So if you consider this as a reference line and from here to the peak voltage, that is the peak, it's the same as the bottom side also. But the only thing is it's going to differ in the angle. Okay. It's going to differ in the angle. So this is called as out of phase. So initially in the input, I'm giving the positive cycle, but in the waveform at the output I'm getting a negative cycle. So this tells us that our amplifier is working really good. Okay, so after confirming this, we can go for the PCB schematic. Okay, that is the PCB layout. So I'm just clicking on this PCB layout. Yeah, before going to this PCB layout, what I'm going to do is I'm going to make some necessary changes in the circuit, because oscilloscope cannot be embedded onto the board and the power supplies also cannot be embedded onto the board. They have to be transferred from outside the board. So for that, what I'm going to do is I'm just uh, pasting some headers, and for that I'm going to make a copy of this circuit and I'm going to place a circuit here. Okay, so in order to not get confused, what I'm going to do is I am going to name this as 741. So for the PCB layout, it will be much easier for me to understand. Okay. Now, so yeah, it has changed its name 741 and 741, right? What I'm going to do is I'm going to remove all these voltages I'm just going to remove all these voltages, and yeah, the oscilloscope also. I'm going to keep it this way. Then I am going in the component modes and selecting a single pin header. One pin pin header. So this is a two pin. If you see the description, that will be much better. Yeah, this is the one pin header. I'm selecting this and I'm placing one here, one right here, one I'm going to place it here, and I do need to give ground, right? We will see about it later. X-axis, and I'm going to connect it like this here. This one, pin number 4, pin number 7. So pin number 7 is plus 15 volts, so plus 1 5. This one, let me hide the labels. So this one will be minus 15, and this one will be the input. Okay, so this is the input. Now what I need to do is I need a point from where I can check all the outputs. So for that, what I'm going to do is I am going to select a header. So yeah, I'm going to select a header which is of 3 pin. I will tell you why 3 pin. 3 pin, yeah, 3 pin header. I believe it is of the same number. No, so yeah, this one is it. No, so 266301. So yeah, this is the series. This is the 3 pin header. So I'm selecting this one and I'm placing that particular header here. So for this, I'm going to select the pin number 1 for the output and the pin number 2 here. Okay. So this could be a little bit confusing when you're going to design, but yeah, this will be a confusing. So instead of that, I will go for 2 pin headers. 2 pin header, 266. Yeah, this one. So 2 pin header, one for the output and the other one for the input, like this. Now these two pins, what I'm going to do is I'm just going to ground these two with the help of a terminal, which is nothing but ground. So what I'm going to do is I'm just going to rename this as GND and this one as GND. Okay, that's it. So this is the complete, yeah, this can be written as out wave. Okay, and I don't know is this part number, and this one will be in wave, and yeah, I'm going to hide that like this. So this is the final setup. Now when I go for the PCB layout, what I'm going to do is I'm going to place all the parts one by one, or else you can just auto place the components. But for that, you have to place, first of all, you have to place a box. You have to define the board edge. So I'm going to take it as big as possible. Then now what I'm going to do is I'm going in the tools and I'm selecting the placer. So these are the things that have the blueprint. I don't need U1. I don't need R1 and R2 also. So these are the components that I need. I'm just going to click on OK, and the software is going to place all the components for me. Okay, so this is the final thing. Now what I'm going to do is I'm simply going to adjust all these components so that it will be much easier for me to place the components or to route them. So yeah, I'm going to keep it somewhere here so that this this and along with that where is it minus 15 this comes. Oh, I need to select this component more. So these will be placed just beside each other. So rotating it clockwise and clockwise to keep it perfectly aligned or in the orientation with this. Okay. So this is the basic task. If you do it properly, if you align your components properly, the routing will be much better. Now the output wave will be at the output side. So yeah, what I'm going to do is I'm just going to move this component here. And for better routing, what I'm going to do is I'm routing it anti-clockwise direction. The R3 and R4. So check the schematic. R3 is the input resistor. So the input, if you observe here, the inverting pin will be at 2. So this should go, the R3 should go at the left side of the IC. So this thing goes there for pin number 2. Okay. Pin number 1 is connected, so it's better to rotate it 180 degrees, and this will be much better. The input part, this component, I am placing it here. This one is also will be rotated by 180 degrees. Yeah, the rotation I'm making is 0 degrees. uh, and I'm going to place it here. So it will be clearly visible for me. And yeah, you can move this to the bottom. So when you route, you have a clear view. The out is placed. I need a feedback resistor, so I just going to place the feedback resistor here. Okay, and what is the other thing? The input wave. So for checking the input wave, this what I'm going to do is I'm going to keep it both side by side, just like this. So it will be much easier for me to take the outputs. And this one I will move a little bit upside, so routing will be much easier. Now I'm just going to select the track mode and clicking on this I'm just going to connect. Yeah, I'm taking a bottom copper here instead of top copper. I'm going for bottom copper. So select this one and select this one, that my routing is complete there. Now what I'm going to do is I'm just going to connect this with the inverting, correct the R3 resistor with the inverting a pin of 741. Now this is connected to pin number 2. Instead of connecting it there, what I'm going to do is I'm just going to connect it connecting it here like this. Okay. Then the yeah, these are the straight pins, so these will be easily connected. Uh, this should be connected with the pin number 7. So instead of going outside, I'm just going to route it from the inside. I'm just going to route it like this. Okay. Now for the output part, the feedback resistor. For the feedback resistor, I'm going to fix it like this and route it. Okay. Yeah, this route is not a bit good way. I'm going to route it like this, and it will be better if I move these two a little bit inside and upward. Okay. So this one is connected with the ground. See here, the pin number 3 has been connected to ground. So I need a terminal to connect it to the ground. Before that, I need to get the output, and for checking the output, I need a point. So that particular point will be this one. Oh yeah, it's a component mode, right? So I go in for the track mode and placing it like this. So that's complete. I need a ground pin, and along with that I need to connect this here. Now that's going to be a little bit troublesome. Yeah, I will route it outwards. So clicking on here. No, the ground has to be connected here. Okay. Hmm. So yeah, I have to connect this pin number 3 of 741 with the outway of this pin. So for that, what I'm going to do is I'm going to make some rotations. So instead of that, isn't it any easier way? Like going this, just like this. And yeah, I can move that from the outside. That is also possible. That's much easier. Just selecting here, keep it short. And yeah, okay. So this will be better. And yeah, so this will be much better. Now to connect this path, simply what I'm going to do is I'm just selecting this one here, and I am running a trace like this. So you can just go over the labels. I am just trying to prevent those labels so they will be much neatly visible like this. I'm just trying to skip these labels so that when you go for the 3D visualization, you will get a clear view of it. So that's the complete connection point. From here you will give the input, and from here you will give the positive and negative power supply. But if you observe here, we have not given the power supply to the pin and the ground for the particular 741, the particular power supply voltage and the particular ground pin, because those two will be satisfied, or those two will be overcome for the as we are connecting the pin number 3 to the ground, and the plus and minus negative voltages will do the trigger voltage pins like triggering and all. Okay, so this is the complete part. Now just to resize this thing, what I'm going to do is I'm just going to reduce the board. That's it. And I'm going to see the 3D visualizer. So yeah, this is the complete board. Okay, so yeah, the reason why I have not rotated it, because on these levels for getting a clear view on this. Okay, so this is the complete routing part. This is the complete routes that I will be getting uh, when I do the printed circuit board. Okay, so this is the complete printed circuit board. And in order to get this, the printable, that means the ready to print, just come to the PCB layout, click on output and select the print layout. Yeah, what I need is just the, I don't need the top copper. I need the top silk, and top resist, bottom resist are not needed. Board edge and bottom copper are necessary. If you remove this bottom copper, you will just get the top silk. Now, if you remove this also, you will get a blank paper. Top copper, there are, what are those? So let's see what are those with this top copper, just the top copper itself. I have selected it. Now, okay, it has gone for the print. So output, print layout. I just need to change this into PDF. Okay, so I don't need the bottom copper. Okay, let us select this one. This is inverting amp. So this is the top copper part, and when you go for the bottom part, so that was the top copper. So yeah, top copper means it's saying these purple things. So now let us try only the part instead of top copper. So print to PDF. Yeah, INV. So where is INV? It's opening. Okay. So routing is there. Other than routing, what is missing? Nothing else. So this is the bottom copper and the complete layout. Now what will happen if I remove this top silk? Just a minute. I believe I have not selected the. This segment for the print again. This is the thriller. So this is the complete layout of 741, which is used as the inverting amplifier. Okay. I hope you have understood the process and you have understood the whole procedure. Hope you like the video. Thank you. Hope you like the video. That's it for this video. Thank you.